Yeah, hello, Berlin. Ich bin froh bis hier zu sehen. Das ist eine wunderschöne Stadt und ich kann sagen, ich bin ein Berliner auch. That's all my German, so don't worry about that. No more German for today. I'm here to speak about. It's a little bit of an odd talk for a keynote. I'm here to speak about the future of OpenJDK and the future of Java, looking a little bit at the past of it. So that's a little bit of what's on the menu for today. We are going to see a little bit of history of OpenJDK, how the project came into existence, and how then it works with its governance, with the developers and the stewards. So what is the project composition? And then we will finally explore JDK Mission Control and JDK Flight Recorder, which are the latest 2 bits being open sourced. And finally, we will see why that's so important. And just a slide about comparing with the previous situation when they were still closed. Then finally, I hope to entertain you with a small demo, and hopefully it doesn't crash, so I don't entertain you too much. So, who am I, first of all? So I work for Red Hat. I'm associate manager. I manage a team of about 10 people. I am part of the Java team at Red Hat. My team specifically works on Java Mission Control, JDK Mission Control, since the project was open source, right at the beginning. I've been working on OpenJDK for a very long time, basically before it was existing. I do remember working on, with some people here in the audience, on attempts of getting out of what was called, and likely forgotten in history, what was called the Java trap. The Java trap was essentially the problem that Java as a platform was proprietary software. At the time, with some restricted license, and there was no free software equivalent, especially problematic for free software distribution of Linux, because obviously there was stuck what had to be open sourced in free software. And most of the Java stuff was free software. The problem was the platform itself was closed. So that was the Java trap, getting developers using a proprietary JVM, even if they wanted to run a full open stack. There were some implementation. ClassPath was the most famous one, and the most important was a class library in itself. It wasn't a Java virtual machine. There was a number of Java virtual machines. GCJ, obviously, was a ahead-of-time compiler. Café, JamVM, and yeah, you name it, many of them. Clean room implementation of the Java virtual machine. Then what happened? A night about, I think it was, don't remember exactly the day, but somebody was calling us on IRC on the ClassPath channel for a really huge event that was live streamed, and then also on IRC with questions, and that was the Liberation Day. Java-C and Hotspot first, and then Sun announced that before the summer, the coming year, they would release everything else. There was a huge keynote of FOSDEM that year to announce that. That was very significant. The 8th of May 2007, that was Java Liberation Day. It was finally freedom. Java, OpenJDK was born, Java was free, the Java trap was finished. That's a quote from Richard Stallman. It's very significant from Stallman itself, the end of the Java trap. A friend of mine, Andrew Hughes, said, no, that's the problem here is going to be about building a community about this thing, because the code is there, problem solved. So this is how, what we are going to discuss today. We will see this journey and how this community evolved and how it worked out and how it is about. It was a little bit of a bumpy ride. This is the ClassPath mascot with Duke, you know him, going celebrating Christmas somewhere. Okay, So what is the composition of the project itself? So I want to thank, first of all, Mark Reynolds for these ideas. He had a very nice presentation. I've posted them. This is online. I really would like you to go and see it, because he's speaking in more details about how the composition is done, so the difference between developers, stewards, and governance. So I will only touch briefly on that today. So there is the community is structured in a way that all revolve around the developers. So the developers are the key for the OpenJDK community. Everybody is a developer. They may be different interests about the areas of development, and some of those people tend to be a little bit more into some specific areas, and they want to have more collaboration on bringing the Java platform forward. That's usually when the stewards come into play. So a steward is basically a developer that has a very significant history of contribution, and they want to have those contributions to impact the future of the Java platform. Typically, stewardship is meritocratic, so it's about recognizing the contribution that the steward did, but it needs to be, there is a very high entrance barrier. I mean, everybody can be a contributor as long as he's there contributing, and then if he wants to be a steward, he needs to contribute more to be a steward. It's all about a meritocratic approach. Then there is the governance itself. This is a legislative body. It's not an executive body. That means it doesn't have really anything to say about the inside of specific projects, but it has to say about how the project structure are being accounted for, what is the structure has to be about, and how the various legal things about project had to evolve. There are two components of the governing board. One is the at-large seats. Those are typically chosen by the community and by vote of all the OpenJDK members. And in the last few years, well, since the beginning, that has been Andrew Haley and Doug Lee. And then there are the stable members. Those are not chosen by the community. They are appointed by Oracle and by IBM, and they are basically George Saab, John Duymovich, and Mark Reynolds, and they are stable seed. The community evolved through years. At the beginning, there were a lot of problems, right? Yes, the SourceWorks was there. There were binary plugs that you had to put into the OpenJDK in order to compile. So the Java community started working about liberating those extra bits. At the beginning, it was difficult, and then it was less difficult, and then it was still less difficult. And finally, there was the problem about compliance, and then the TCK compliance came into place, and there is a licensing for OpenJDK. Then there is a problem, because the JSR was still a little bit too close, and so how to contribute to this process and make sure that new libraries and new framework will get into the OpenJDK, integrated new features, added, and so forth. And then the JSR process was slowly liberated as well. Now today it's a lot easier to contribute to the JSR. But then again, it was still a little bit too much for a reference implementation to go first to the JSR, and there was a need for testing feature and to make some experiments and then proposal and see the implementation that had to be in the open, and so the JEP system came into play. And the JEP system is a very interesting way of proposing features. Sometimes they can be experimental, sometimes they just get scrapped altogether from the build. But the JEP system makes sure that those features get into their way in the reference implementation, and so that the JSR that takes care of well, a little bit more than rubber stamping, but it's there to ensure that there is a compliant framework for the JDK. Then you can say, okay, those JEPs are in the reference implementation, so now we get them as an official exactly, it's an official OpenJDK version. Then I'm talking about reference implementation. That implies that OpenJDK has been the reference implementation of Java for quite a long time. I think that was really shortly after the beginning, in fact. Java 7 was the reference implementation already. Java 6 is a little bit different because if you remember, OpenJDK 7 wasn't out yet when Java was liberated, and that was the version in development, but JDK 6 was already out. So what happened is that the community backported feature from JDK 7 from OpenJDK 7 to create what was the JDK 6, and that's the reason why it wasn't the reference implementation for 6. Then there was the issue about bug database. Back then, that was a pain point for a few years, actually. FOSDEM, I remember the long discussions about that. There was no easy way for the community to start contributing bug fixes and see what to work on. It was all behind the old Oracle, the old Sun bug database system. So the OpenJDK community started to work with Oracle to host a server for a Jira instance that could be used for the Open Bug database. So much, in fact, now, that if I'm not mistaken, this is actually the system that is used also for the closed version, the Open, even if the gateway is still the bugs.sun, if I remember. Then there was the problem about security and vulnerability. How do we share patches? This is an hot topic because it's not really as simple as say, okay, I have a bug here that is going to destroy, I don't know, some billion of servers, and then I just send a patch on the OpenJDK mailing list and I get it approved. There is needs of some coordination, some secrecy as well. So this is how the security and vulnerability group, which is like the latest addition to the OpenJDK community, was born. Then there was the issue about what to do when we have older versions and we want to maintain them. We want to give a possibility to the current maintainer to basically step out of the maintenance work and make other people step in. So the OpenJDK community decided about some, still a little bit under discussion. I believe it was kind of fine-tuned in the latest months, basically, but it's still a little bit under discussion how exactly. But there is a way for new maintainers to step in and say, for the old maintainers to step out and say, okay, I want to pass over maintenance work. And then the most important aspect of all, yes, OpenJDK is a project, and every build of OpenJDK is a derivative of this OpenJDK, and this is what forms Java. There are proprietary builds, and those are from Oracle, and then there are builds that have to be open sourced because of the GPL license in OpenJDK. GPL plus class path exception, if you remember the first slide, you get a very nice in there. And so what Oracle did, at the end of the last year, I believe, if I remember correctly, was to decide that they didn't want to have any more proprietary build in the old sense. They wanted to release everything that was making a difference between the closest builds and the open build. And so they started to offer GPL builds to the community. They are builds of the latest version of the JDK, and in particular the version that Oracle is maintaining. And then they started to open source everything that was still part of the closed builds. That's kind of the topic of today's discussion. So I say every build of OpenJDK is in fact a downstream distribution of Java, and there are a few of them, vendor specific, some free software. Then there is the Oracle JDK. Obviously Oracle JDK is here in this picture because it's being part of the community is one version of OpenJDK in itself. So there are lots of ways to get those builds. You can probably just type, if you are using Linux or version of variant of Fedora, you just get, I don't know what's the command today in Fedora because they keep changing those. It was used to be yum install or something. DNF, I believe today, is it? Too fast for me. Then there is the OpenJDK build. Those are interesting. It's a project that is offering builds for various platforms that you can see and test. Especially interesting when for you it's difficult to get builds elsewhere. For instance, they are offering for Mac OS and things like that. Then there are Sub, Azure, Amazon, lots of contribution from the community. This is very interesting. And in order to differentiate a little bit this offer, then what happened was the introduction from Oracle of the idea of having long-term support releases and short-term support releases. This is not something that is part of OpenJDK, however, because from the OpenJDK point of view, every release is just the release, and then it stops being the release in the moment that there is no maintainer maintaining this code. It can be Oracle, it can be Red Hat, it can be anyone else. And in fact, there are a few versions of OpenJDK that are currently being maintained, and they are considered a little bit long-term support. OpenJDK 11, 8, and 6 are all being maintained, and the current version is 12 with 13 coming soon, I believe. I don't remember exactly the dates. So you see, there is a really very wide ecosystem that is built up around the openness of the JDK. Now, I want to thank again Mark Rhino for this and the next series of slides. I asked him to send me what are the JEBs that the community is contributing to OpenJDK. And this is the list, and you see it is really comprehensive list. Highlighted in yellowish are the contribution of the community non-Oracle. Everything else is the community Oracle builds. So this is for the Java 9. It's really a long list, obviously. Then faster release cycle means a little bit less feature, more time to standardize on them. And this is again for Java 10. You see a couple of features, JEBs contributed by non-Oracle members, and the rest Oracle as well. Here as well. This is the list for Java 11. We have another garbage collector. This is Epsilon. And I believe that Shenando has been also integrated in 11 at this point as part of the, or maybe it was in 12. Maybe, yes. Yes, Ali. I have the slide here. It's in 12. So Shenando is part of, and this is a garbage collector contributed by the community, in particular by Red Hat in this case, that is part of the standard distribution of OpenJDK. You download the sources, you build, and Shenando is there. This is the link for the binary builds I was saying before. Again, the binary builds are not part of the project in itself, so OpenJDK doesn't really give binaries. Those are courtesy, in this case of Oracle, for the 12 builds. So overall, what is important about all this, this message is basically that the Oracle stewardship helped opening the Java platform. And the level of competition in favor of something that is more important, adoption and collaboration. There is no one single entity that can do this all by itself, and this is why adoption and collaboration are so critical for the future of the Java platform. And of course, a fast release schedule may mean some disruption in some people, but the important part there is to always understand that faster release cycle doesn't mean that the version that are not long-term support by any given company are lesser good or they are beta versions. This is a common misconception that is important to overcome. They are all very stable, and that's the main reason why we have this faster release schedule for them, is in order to encourage more participation, get the time to do the feature right, have more time to give the feature to the community, to the community of users in particular. And that's also something that happens within the community itself. Every collaboration on OpenJDK is a community collaboration. And of course, there are companies like Oracle is giving a large number of patches, and is also have a large number of developers working there. So obviously has a little bit more weight in some of the things. But when it comes down to the community, everybody is really equal as long as there is a contribution. Now we get to the point of today. So there was a little bit a missing piece in this feature. It was all very, very well and done, but there is still something missing. OpenJDK as a platform never really had a proper tooling, even though it had some support for your agent, for instance. Never really had some proper tooling to get analysis of how the behavior itself of the Java platform is, or the Java virtual machine, or some of the libraries that you may use. So there wasn't a standardized way. There were a large number of tools. Some of you can recognize that the picture. That's just a sample of the alternatives, like Visual VM. There's Thermostat. Selfish plug here because I've been working with Thermostat as an analytic platform for the JVM for the last few years. Flame Graph that used in conjunction with Perf, they allow you to explore a little bit more of the data, so what happens inside the Java virtual machine without the trickery that the instrumentation does to you, because the Java virtual machine likes to lie to the users about what it's really doing under the hood. So once again, there were a few things not standardized. Maybe using some standardized API in the serviceability project, but not really part of the JDK. And there was something needed that was part of the OpenJDK. Sometimes you had a problem with, those monitoring platforms that incur too much overhead, trying to get, for instance, getting, app dumps and trying to analyze those app dumps. This is really a killer for performances. Or tracking object usage in maybe real time. If you try, this is going to be really fun. Sometimes to overcome this, they would be traded just a little bit of accuracy, maybe too much of that. Or they were too specialized, and so user had to start using a multitude of those tools in order to get their job done. With the introduction of Flight Recorder, most of those problems were fixed right at the beginning, because this is a JEP, so it's an official API. It is part of OpenJDK. It's integrated in the Java virtual machine, so the VM knows about the events. That's important even when you are outside of the scope of the JVM itself, thinking about Graal, for instance. Should not name it that here, but anyway. The events are part of the JDK, as I say, and they're designed to be efficient. The way that we use events in the JDK is designed to be extremely low overhead. Even when enabling a little bit too much of them, the overhead can still be accounted in about 2%. Of course, you can always do worse and start analyzing every single thing, and then the overhead grows, but overall it's very efficient. There are extensions for the API. There are Java extension, and they are living in the JDK.Java Flight Recorder JFR namespace, so you can start instrumenting your application. We will see a demo of that shortly. Then finally, this was all open sourced in OpenJDK 11. That was really a big part. It's part of the serviceability API. However, Flight Recorder is being developed by the hotspot people. Features are added every time, and it's very well maintained. That's an example of the API. In order to define an event, all you have to do is to get a class, extend the event from the JDK.JFR namespace, and then you have a bunch of notation that you can use in order to help the tooling, which is most probably Mission Control, to visualize the information. You can give some meaning to the data. You can say this is a string, is a message, it's a label. So this is mean for labeling something. But it can be something like a double, a number, and then what it is that this is a quantity, or maybe a frequency. So there is a large number of APIs that you can use to define correctly what is the event. And then in the moment that you need to commit the event to the event buffer and then to the flight recorder eventually, it's simply about one method call, which is this commit here. How how do you read those events? So the way flight recorder works is that every now and then, and that's something that you start configuring from the command line, it start writing the events on the file, on a file that can be used by some application. It's a binary format, it's very efficient as well. And the units of events that the flight recorder has is called chunks. This is about the smallest things you can have, but all those chunks then form the large flight recorder file. You can keep asking flight recorder files. And again, there is an API in the serviceability, and we will explore that in a few minutes. This is code. These events are being read usually. There is also tooling inside the OpenJDK that does a little bit of analysis, but the best way to collect those events and understand them is by using the tool Mission Control. It was also open sourced last year in May 2018. Mission Control offers a lot of APIs as well. So it is possible to use part of Mission Control without using the full Eclipse-based IDE in order to create your own applications that are that are using the API and can start monitoring and doing performance analysis without the full IDE. So maybe from command line, server-based, serverless, as we've seen before. So having a multitude of different deployments that don't have to be necessarily on the user desktop or the admin desktop in an old-fashioned way, but they can be in the cloud, for instance. Mission Control was open sourced. We started contributing right at the beginning, and we have already RHEL, VSCL, and Fedora releases. So it's possible if you're using a Fedora derivative like CentOS or Fedora itself, you can start working on that right now, and there are packages. On the other hand, there are also builds available on java.net from Mission Control. Those are preview builds, however, because officially the project is still not being released, and I'm really looking forward for the official 7 release that was supposed to happen in December. For some reason didn't yet. Again, APIs, I say, so all that can be done by the IDE or by the standalone Eclipse-based application, but it can be done by your application as well. This is the smallest self-contained example that can read a flight recorder and then create an HTML report out of the recording. This is using some interesting functionality that gives an hint to the developers about if-shoes that they're present in the code without doing any analysis manually. So you don't have to look and see what is the memory consumption to see if there is a memory problem, because the report is pointing you to a memory problem already. If there is a garbage collection issue, the report is going to tell you, look at the garbage collection because this is a problem right there. And maybe it's also suggesting how to correct in some cases if there is an issue with I don't know, network transfer as well. Again, a little bit more complex example. I don't think I want to go too deep into that. It's just about explaining some of the API. In this case, is for creating aggregate reports based on average standard deviation of some metrics that is part of the Java recorder, the Java flight recorder file that is being triggered. One more thing about that is like to say the API is very interesting. It's really akin of the streams. Maybe if you go back one step, it doesn't, even if it's not targeted at JDK 8 and below and beyond that, you can still use that with JDK 7. And I believe in 6, but I don't want to be, this is quoted on that because I didn't really try that. It's very similar to how you will do analysis with streams. So you rarely access the single chunks. Actually, this is very discouraging. And what you generally want to do is to get averaging reports, so analysis that encompasses the whole range of data. I was saying before, there is a little bit of significance here. Why Java Mission Control, Java File Recorder, JDK Mission Control, and JDK File Recorder have been open sourced, and they're very significant for that. Java has been a really long time in the opening now. We've seen that at the beginning since 2006. But still, some parts kept growing in the closed world, and they kind of get this interesting thing where Mission Control File Recorder for a long time was considered to be the value add of having a closed version of the JDK. So this is something very important and significant Oracle did to open source this last bit, so to totally level the field. There was a little bit of work there at the beginning. I think in Java 11, an events API was introduced. It was mainly for making it easier to backport patches between File Recorder and the main line, but it wasn't enough, obviously, because that was something that was never really used by the community, and at large, it was only used by Oracle specifically for easy backporting. That until 11, but not anymore. So when 11 was out and Java File Recorder was finally there, this is where things changed. And it wasn't hidden anymore behind a restricted license. At this point, you can avoid using the allow commercial feature, and this is there in OpenJDK. Whatever distribution of OpenJDK you are using, this is okay to go. Check the license. The community engagement was very high from the beginning. We started to schedule calls with Marcus here. This is the project lead. It was, I think, at the beginning almost on a weekly basis. Over time, a little bit less than that. Anytime it's needed, though, there is a call. We have a multitude of channels for communication. There is the IRC that we helped setting up at the beginning until we kind of migrated to Slack, but IRC is still there if some of you, like me, prefer the old systems. Then we started sharing bugs and backlogs. So for instance, what are the features that would be nice to do in the next version? And this is something that is one of a kind. OpenJDK is doing that already now with some of the features and the job process. But this is the first external project that is still kind of in this environment of OpenJDK that is so comprehensive. It never really happened before. We have OpenJDK backlog for Java Mission Control, or JDK Mission Control, forgive me. And there's been a lot of collaboration externally already. When externally, I mean not Oracle community members. There have been a lot of contributions, some from Google, other people, some standalone developers, some other companies, and obviously Red Hat has started to contribute very heavily, and we are kind of accounting 1/3, last time I checked it, maybe a little bit different now, of the whole contribution to the project. So we really valued this a lot, and we wanted to jump on that and share everything and all our knowledge to improve that. So kudos, Marcus. Really, really awesome. Thank you for doing this. Check out this blog. There is a lot of information there for how to use Mission Control and File Recorder. So now the demo that I'm hoping it will work. Otherwise, I promise you to be entertained today. So first of all, I just have to get out of the presentation. Yes. First thing first. So this is how Mission Control looks like. As you see, it's very boring at the beginning. There doesn't seem to be a lot of stuff happening. There is a classical ambient server This is very similar to what you find in tooling like, I don't know, Visual BM and something. So it's not very exciting. There is a little bit of stuff going on there, but nothing really, wow. But it's interesting because you can start, so with MBin, you can start controlling the behavior of the virtual machine. So it's significant that it's there anyway. And we will see later an example. And then you can start getting the recording. How a recording looks like. This is the, yes, we want to do the automated analysis. This is the very first page that you see. And if you're using the API that I showed before about creating a report, this is what it does. You can click around and it send you to the right page for where the action is, and then you can see, okay, there is a little bit of biased deblocking going on, and there is an explanation of why it is happening, where it's there, and if it's a problem, you should look at. Then it gives you direction to where to see the project. Thrown errors, obviously there is a lot of errors that are normal in the JVM initialization, but the tool is smart enough to understand most of those situations. So it can tell you if this is something that is particularly high but is to be expected, or if it's something that you have to take care of. Okay. Then let's go to the problem at hand. So this is a very silly demo that I did today. As you can see, I'm not a developer anymore. What happens here is that there is a robot shop, and there is some kind of place where those robots are being created. In reality, this is just junk. It's just objects that keep being created. And then there is, the shop is asking those robots to be sold. The problem is that the robots are really, creating a lot of them. There is a little bit of delay, which is not really a smart way of creating robots and trying to not have too many of them in your, park there. So this is not really a way to control production. But this is how the developer did that. They weren't really very good. And so the problem is that now this demo is creating a lot of robots, and the code that is consuming them is also not very smart. It's just sleeping a little bit, and then from time to time you say, oh, I want to have the next order. So what happens here is that there is a very big discrepancy between the number of robots that are being created and the number of robots that are being consumed at any given time. And you can see that from here. It keeps growing and growing and growing and growing for forever. That's a problem, because that means that you have in production a lot of robots that just have to stay in a warehouse until somebody buys them. That's not really efficient. But luckily, the developers, we didn't have any real protocol in order to give this information. They were using Mission Control to get some statistics. And that's what they did. They finally got an event for storage requests, and the events always say, okay, what is happening here? How many robots do we have at any given time, and how many robots we are selling? The selling is a little bit silly, just always one every request. This server is very important for the company. They cannot take it down to amend the code. They don't have any more developers for doing this kind of job. So this is really critical. So they hired a guy that knows everything about Mission Control. And what he did is say, okay, what I can do, I can use the Mission Control API and do some magic there by getting some statistics. Very simple statistics, this is really simple. If there is, I'm just getting the events, and I'm trying to get how many of those robots are being created every now and then I try to slow down, which is the only thing that the API gives me possibility to do, the production based on the number of robots, so that I can kind of equalize the number of robots. And now this is a really high number, so this is going to take forever to do that, but I will show you anyway in production. With the number of robots, so what is happening here? Remotely, we are asking, so this is over the network, even if it's all local, obviously, on the system. Remotely, we are asking for a flight recorder file. And this is done here. It's using all the standard Java API. There is nothing really special on that in the management. So the management bin is asking, is attaching to the VM. It's using standard API. This is OpenJDK 11 and modules compatible. It's connecting to the service URL via JMX, and then it's asking for the mbin, that is the Java flight recorder mbins. And then it's asking for a recorder. You create a new recording by asking an ID, and then those ID can be stored there, and then you can ask the recording anytime. And then it's saving it to a file. This works over remote, so the transfer is actually over the network. And then the file is stored. Whenever this file is there, the robot is here. It's reading the file, and then it's analyzing it. In this case, we only use an aggregate quantity. We want to have the average of the events that we created. If you remember, in the logging, this is the event itself. So basically what we're doing is to get those fields, we're reading them, and then we try to get them closer to 1. This is a very simple, I mean, this is not machine learning thing, anything, it's just a division. But eventually you can do something more interesting over there and start using machine learning to get proper difference between the production and the consumption, and try to get a minimization problem over that. So this is a silly example, but in fact it can be used in real life. And yes, what is happening here is that you see here, it's basically increasing the threshold. The threshold is the delay that we saw at the very beginning, which is here. So this is the threshold. We started with 100 milliseconds, and now it's about 3 seconds something. And then it keeps going until it reaches a point where things are a little bit stable, and then it will start increasing and decreasing this delay again and trying to optimize. That's all for today, for the demo at least. And oh no, we have questions coming, I guess. 3 minutes. Yep. Some questions? No questions. We have 3 minutes to spare. This is magic. Okay. Just hop on the project mailing list, get your stuff, contribute, see the demos. We're preparing a lot of stuff. In the future, we are hoping to get more code out in the wild and make more use cases, for instance, in a cloud environment, which this is extremely useful. Done.